Alright, welcome back, chemistry kids. Today we're going to be talking, this is the last day of notes about our acids and bases in liquid solutions in general, and we're doing the hard stuff now. We're going to talk about neutralization. How do acids and bases actually cancel each other out to create neutral solutions? So a neutralization reaction occurs whenever you have an acid mixed with a base, and it creates water and a salt, where a salt is any ionic compound. It doesn't have to be table salt, NaCl. It could be KCl or KBr or who knows what, anything that's ionic. So for example, if you have hydrochloric acid and sodium hydroxide, the H and the OH form H2O, and that leaves the Cl and the Na, NaCl, salt. So theoretically, you could take hydrochloric acid and sodium hydroxide, and if you balance them out just right, you get salt water. I still wouldn't drink it, but, you know, shouldn't drink salt water anyway. Okay, so how can we apply this? If you have a liquid that you know is an acid or a base, but you don't know how strong it is, you can neutralize it using a known acid or base and use that to figure out the strength of the unknown. This is called titration. It's a method used to determine the strength of an unknown acid or base by neutralizing it with a known acid or base. You neutralize it until the two liquids mix at the equivalence point, where the moles of hydrogen ions are equal to the moles of hydroxide ions. So H pluses equal OHs, and that produces a neutral pH. And there's ways to do this in real life with, you can use a pH probe and just keep an eye on it, and when it hits 7, you stop adding the liquids. Or you can use chemicals that change colors at certain points, stuff like that. Usually there's a nice long lab about this, and it's a lot of fun, and we're not getting to do it this year, and I'm kind of bummed out. But, sorry guys, no titration labs this year. But we're going to talk about the math involved anyway. There's a lot of steps, but we've done all these steps before. First of all, you have to have a balanced equation. Usually, under more normal circumstances, I might make you balance them yourself, but in this case, I'll just give you balanced equations to work with because there's plenty of other stuff to do. Then we're going to calculate how many moles of the known that we use using our molarity equation, where moles of solute equals molarity times liters, or potentially by doing grams to moles conversions, which you divide by the molar mass. Then we use the mole-to-mole ratio to convert it to moles of the unknown, and then finally we calculate the molarity of our unknown using the molarity equation again, molarity equals moles per liter, or to grams of solid if necessary, doing moles to grams. So there's lots of different ways this can kind of go. But it's all math we've done before, we're just chaining it together. The easiest way to do this is look at an example. So I typed this all out for you guys. It took forever. But I'm going to skip step 1 because, like I said, I'm just going to give you a balanced equation. So here's our example. If we have 25 milliliters of sulfuric acid, H2SO4, that's neutralized by 18 milliliters of a 1.0 molar sodium hydroxide solution, we want to find the molarity of the sulfuric acid, the H2SO4, because we know the molarity of the other one, the sodium hydroxide. So the balanced equation, whoops, there we go. Too far. Sure, the balanced equation is here. And I explain all the steps to balancing it, but we don't really need that. Basically, it's H2SO4 plus 2 NaOHs makes 2 H2O plus Na2SO4. So there's a 2-to-1 ratio between the NaOH and H2SO4. So we need to calculate how many moles of NaOH we used. We had 18 mils of 1 molar solution, so 18 milliliters, we need to convert that into liters, so we divide it by 1,000. That's 0.018 liters. To calculate moles, we do the molarity times the liters, and so it's 1.0 molar times 0.018 liters equals 0.018 moles. Then we need to figure out how many moles of H2SO4 that would be. We just use the mole-to-mole ratio. We take our answer from step 2 as the moles of NaOH, and then we use the coefficients from our balanced equation as the ratio. So it was 0.018 moles of NaOH, and from our balanced equation, it was 1 mole of H2SO4 to 2 moles NaOH, so 1 over 2. So 0.018 times 1 divided by 2, 0.009 moles of H2SO4. And then finally, to calculate the molarity, it's moles divided by liters. We're told we had 25 milliliters. We need to convert that into liters. So 25 mils divided by 1,000 is 0.025 liters. And then we take the moles divided by the liters, 0.009 moles, which we got from up here, divided by 0.025 liters is 0.36 molar H2SO4, and that's our final answer. So yeah, we're not going to do very many of these. Don't forget that on the homework, you can submit it as many times as you want. It's not going to tell you the correct answers, but it will tell you if you are correct. And so if you get one step right and the next step wrong, at least you know where you went wrong. And again, you can email me or text me or chat with me from 1 to 3 in the afternoon on the Google chat room doc, the science chat room doc, and I can help you with this. I know this is kind of complicated. There's just a lot of steps, but I think you guys can do it. So I have faith in you. And then we're going to have a quiz on Friday, and on Monday we'll do an online titration lab. That's the plan. But anyway, see you next time. Bye.